Hey chemistry students, this is Miss Ruark. This is Vodcast 4.5. I'm going to teach the difference between an empirical and a molecular formula. All right, so looking at these two compounds here. Here we have our ionic compound, which is sodium chloride, and here we have our covalent compound, which is hydrogen peroxide. Now, just looking at the two, this is a formula unit or a set of formula units of a sodium chloride compound, which is ionic. And remember when we were writing these, I told you that we always simplify our ionic compounds. Well, the reason for that is because it's like a network of sodium and chlorine atoms that are bonded together or pulled together. Whereas in a covalent compound, we don't simplify them because it is simply two hydrogens and two oxygens. And we can't show the number of sodium chloride or sodium and chlorine atoms because there could be numerous. We just show the ratio of metal ions to nonmetal or positive ions to negative ions. Whereas in a covalent compound, what you see in the formula is what you get. Okay, so that being said, we have to tell the difference between an empirical and a molecular formula. Okay, so let's learn the difference. All right, so let's go back real quick. Here, the empirical formula, this would be considered an empirical formula because it is the simplest formula. Okay, so the empirical formula, might want to write that down somewhere, is the simplest formula that you can find for a compound. Okay, this formula here would be considered a molecular formula. And the reason it's molecular is because it shows the actual number and the type of elements that are involved in that molecule. Okay, we could simplify this and make it HO. That would be considered the empirical formula for this compound. Numerous compounds can have the same empirical formula, but as far as a molecular formula is concerned, that is specific to each individual compound. All right, what in the world did you just say? That made no sense. Okay, let's make sense of it. All right, so it says to write the empirical formulas for the following compounds. Well, here for propene, we have C3H6. To write the empirical formula or the, or the simplest formula, you have to simplify it. So we can pull a 3 out of each and we can make this CH2. Oh, it's that simple? Well, yeah, kind of. All right, so ethene, we can pull out a 2 and make it CH. Okay, for glucose, we can pull out a 6 and make it CH2O. And for octane, we could pull out a 2 and make it C4H7. Okay, so these molecular formulas are specific to those individual compounds. Glucose is the only thing that will have C6H12O6. Okay, ethene will be C2H2. But guess what? We can actually find other things that have that empirical formula, or that empirical formula. Okay, like propene is C3H6. Well, butene would be C3H8. Okay, if we break that down, it's going to have the same empirical formula. So that's what I meant by that. Okay, identify these as empirical, molecular, or both. So H2O, we know that this is water, so it's going to be a molecular formula. The question is, can we break it down further? No. So it's a molecular and an empirical formula, so it is both. Okay, C4H10 is a molecular formula. Can we break it down further? No. Okay, CH. Well, guess what? By the laws of chemistry, because we cannot have a C with one simple H, this would be an empirical formula. Because we learned already that one carbon needs to have more than one H with it. All right, and then sodium chloride. Well, this would be the empirical formula, and guess what? It's also the molecular formula because it tells us, well, that's a lie. We can't really say it's the molecular formula. That would be the empirical formula for the substance. And the reason we can't say it's the molecular formula is because it's an ionic compound. We always simplify our ionic compounds, right? Right. Okay, so that's the easy way. If I tell you to give me the empirical formula for a compound and I give you the formula for it, all you have to do is simplify it. Don't make it harder than it is. Okay, now what if I don't give you the empirical formula? What if I give you masses or percents? Then you have to calculate it. All right, what are the steps that you have to follow to calculate it? Well, step number one, you're going to change all percents to mass, so percents to grams. That's the hardest step there, guys. The very hardest step, and you'll see why in just a minute. All right, and then you're going to change from mass to moles. You guys know how to do mass to moles, right? And then you're going to divide by the smallest mole. And then if you get a decimal, you're going to multiply until you get a whole number. Okay, what in the world does that mean? Well, let's follow the steps. What's the empirical formula? So we're looking for the empirical formula for a compound that's 25.9% nitrogen and 74.1% oxygen. All right, so 25.9% nitrogen, and we've got to change, 74.1% oxygen. We've got to change from percent to grams. Okay, now I said this was the hardest step, so make sure that you're paying super special attention. Okay, if we take 25.9 and we add it, 25.9, and we add it to 74.1, we get 100. Okay, so we're assuming that this is 100%, and let's go on ahead and make the assumption that it's of 100 grams. If we make that assumption, we can say that 25.9% is equal to 25.9 grams. Oh my gosh, I told you it was the hardest step. And so this would be 74.1 grams of oxygen. Told you it was the hardest step. Oh, whew. Hope you guys did that right. Okay, now we've got to go from mass to moles. Now, how do we go from mass to moles? Remember, we go from mass to moles by dividing by the formula mass, right? Divide by the formula mass. I'm going to write that to the side. Divide by the formula mass. So in this case, it happens to be the atomic mass. All right, so 1 mole of nitrogen is equal to 14.01 grams of nitrogen. And then 1 mole of oxygen is equal to, 16.00 grams of oxygen. All right, so 25.9 divided by 14.01 gives us 1.8487, and that's fine. It doesn't matter how many significant figures you keep because we're going to keep going, so don't worry about that. Just keep a bunch of numbers. All right, and then 74.1 divided by 16 gives us 4.63125. Okay, step 2 is done, right? This was step 1. This is step 2. Step 3, divide by the smallest mole. All right, well, remember, we've changed from grams to moles, right? Excuse me. All right, so we have moles and moles. Which one is smaller? Oh, the one on top is smaller, so we're going to divide everything by the smaller one. Okay, if we divide something by itself, we get 1, and guess what? Our units are now canceling, right? Mole divided by mole, they cancel out. Okay, well, what about the bottom one? 0.84867. And it gives us 2.5. All right, so anytime you get something that comes up at a 0.5, it can be a 0.4, it can be a 0.6, even a 0.7. You could probably even go with a 0.3 or 0.35. You're going to round it all. All of these are going to go to a 0.5. Okay, and the reason you want to keep it at a 0.5 is because we have to now multiply by a whole number to give us a whole number. Well, 0.5 times 2 will give us 5, right? Okay, so we're going to multiply 1 by 2 gives us 2, and then 2 times 2.5 gives us 5. We want whole numbers because guess what? These are now going to be our subscripts in our formulas. Okay, so we take the N, there's 2 of them, and the O, there's 5 of them. And that, ladies and gentlemen, is your empirical formula. Don't worry, if I lost you, we will practice when you get to class. Okay, well, what about the molecular formula? What if I tell you I need you to calculate the molecular formula? Well, when we did the empirical formula, or when you write the empirical formula from a molecular formula, you're simplifying it. You're pulling out a number. Well, we got to figure out what that number is to put it back in. Okay, so here's a problem. It says succinic acid is a substance produced by lichens. lichens. I don't know how to say that word. All right, chemical analysis indicates it is composed of 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. It has a molar mass of 118.1 grams per mole. I'm going to write that here. 118.1 grams per mole. That's important. If that's not given to you, you can't solve this problem. Okay, they want to know the empirical and the molecular formulas for succinic acid. Now, sometimes they give you the empirical formula, and if they do, yay, you don't have to do these steps. But if they don't, you have to solve to find your empirical formula. So remember, first step is the hardest. We've got to go from percent to grams. Oh, it's so hard. 40.68 grams of carbon. Oh, 5.08 grams of hydrogen, and 54.24 grams of oxygen. Like I said, that's the hardest step there. All right, second step, we've got to go from grams to moles. All right, so from grams to moles, we've got 1 mole of carbon, and that's equal to 12.01 grams of carbon. We've got 1 mole of hydrogen, and hopefully you left yourself more room than I did, 1.01 grams of hydrogen, and then 1 mole of oxygen, and that's 16.00 grams of oxygen. Okay, so 40.68 divided by 12.01, and we get 3.387 moles. All right, 5.08 divided by 1.01 gives us 5.0297 moles, and 54.24 divided by 16, 3.39 moles. Okay, step 2 is done. So step 3, we've got to divide by the smallest mole. Which one's the smallest? 3.387. So divide all of them by 3.387 moles. Now I'm just going to put a down arrow, meaning I'm doing it for all of them. So that's going to give me 1. This is going to give me 1, and 5.0297 divided by 3.387 gives us 1.48, which would be 1.5. Okay, if I've got 1.5 here, I've got to multiply all 3 of them by 2. So this is a 2, this is a 3, and this is a 2. So my empirical formula is now going to be, we'll write it here, C2H3O2. Okay, that's my empirical formula. Yay, one of them's done. Don't forget to answer all questions because it says what is the molecular formula. Okay, so there's a couple extra steps you have to follow. The first thing you need to do is figure out what is the molar mass or formula mass of the empirical formula. So C, there's 2, H, there's 3, and O, there's 2. Multiply by the mass, 12.01 times 1.01 times 16. All right. So that would be 30, I can't think right now, 36. No, I did it wrong. 12 times 2 is 20. Oh my gosh, what am I thinking? I can't even figure out what 24 is. Oh my lord. Okay, 24.02, 3.03, and 32. Okay, 24.02 plus 3.03 plus 32 gives us 59.05. That's the formula mass of the empirical formula. Okay, so we're going to use this number here. Let me circle it. This number here, and the number that was given, whoa, that was not good, and the number that was given to us in the problem. We're going to divide the molar mass divided by the empirical formula's mass. All right, so 118.1 divided by 59.05, and our units cancel because of the same thing. You're trying to get a whole number here. Okay, so this gives us 2. Well, guess what? This is the number that we're going to multiply by our empirical formula. So we're going to multiply it by C2H3O2. All right, so that gives us C4H6O4, and that would be the molecular formula of our compound. And that's it. Okay, we'll practice when we get in class. I'll see you then.